Following up on what Enrique has presented, I wanted to speak a little bit more in detail about how machine learning adoption is happening in the enterprise, how businesses are adopting different platforms, machine learning platforms specifically, and also provide a quick overview about AutoML, or automated machine learning, specifically for rapid prototyping. So, okay, a quick disclaimer. You will see the term artificial intelligence throughout this presentation. I want to make sure that everybody understands that this is not true or formal artificial intelligence. It refers specifically to the ability to build machine learning driven applications that will automate or optimize business processes. So when we refer to AI throughout this presentation, this talk is all about how we apply machine learning in order to automate or improve the existing business processes. All right, this is a summary of the whole presentation. Actually, the presentation is double that what you will see now, but I will make sure that through the organization we make all the materials available. There are 7 sections in the presentation and a lot of data, a lot of numbers and facts and references, but I'll try to combine everything into this talk, and then later on, if anyone wants to dive into some specifics, I'll be happy to answer questions or provide more links or more materials as necessary. So a little bit about the context and some specific definitions when we refer specifically to machine learning platforms. And for that, there is a formal report from Gartner that the industry is following, in which a machine learning platform is defined specifically as a system or solution that will support the following functionality: handling data, from data ingestion to data preparation, transformation, exploration and visualization, very important. Feature engineering, which is the ability also to develop new variables or new data fields that are important and relevant for the algorithm. Then a machine learning platform should be also able to allow you to do model selection, evaluation of the models and testing, as well as deployment, which is arguably the most important part, meaning effectively that we need to make sure that after we do our machine learning modeling and the model is satisfactory, we are able to deploy the model in production and use it for the actual business purpose. That's a very important part. And after the model is deployed, there is also what we call lifecycle management, which means effectively monitoring and doing maintenance on the model. That refers, I'll speak a little bit later, more details about that, but this refers specifically to the ability to control the concept drift for how the model will get old with time as the data also gets obsolete, the data that we have used in order to train the model. If we zoom back a little bit and now using the framework from McKinsey, in the way that enterprises and big corporations need to look at AI and machine learning in particular, there is one very important concept that is arising here, which is what they call AI assets or artificial intelligence assets. So in the same way that we look at companies and we analyze profit and loss, the earnings, and we have a set of assets that are the core valuation of the company. Now we look at specific AI assets in order to evaluate the ability of a company to be future-proof. And in this slide here, what you have from left to right is a framework for thinking about AI assets. We start with use cases or sources of value, which means effectively those business processes in which you may extract value from applying data-driven strategies and machine learning. Out of those use cases, you have data ecosystems, or the data that will be the source of your machine learning application. There are techniques and tools that you will apply to the data in order to tackle those use cases. And this is a very important part. This is what we call already an AI asset, when you have a machine learning platform and the tools in place in your company that will enable your employees and your managers to effectively develop machine learning driven applications. Not only there, but also moving ahead into the organization, you need to make sure that there is the proper workflow integration. Again, thinking about business processes or existing business processes in the enterprise. And finally, there must be skills, necessary skills, knowledge and understanding of how to drive these machine learning driven applications. So when we think about tools and machine learning platform, this is one of those AI assets that is important in the future of the company to have to be considered as part of the actual assets, and machine learning models could be considered as first-class enterprise assets at this stage. And also in the same way, having the skills and the expertise within the organization, and it's not only the data scientists, but obviously the managers and the leadership of the company, understanding how they can benefit and how they should oversee the different departments and entities doing machine learning to benefit the company. Okay, a little bit about the machine learning algorithms. In the sessions later on, you will have plenty of details from the experts. I want just to provide a very quick overview about the typical algorithms that everyone probably should know. So there are two categories of algorithms, supervised and unsupervised. Supervised means we have data that is labeled, and we use that labeled data in order to train the models. And supervised, there is data, but we don't need to have a specific labels on it. There's certain algorithms like clustering, anomaly, association, and other similar algorithms will be able to extract patterns from the data without the need of having that information labeled. On the left-hand side, we typically work with the simple trees or ensembles that are quick, relatively quick from a computational perspective, and allow you to immediately extract value from your data, build a quick model in order to validate your idea, your use case, or your hypothesis. More complex approaches, and probably with better performance, are deep nets or neural networks, and other algorithms based on neural networks that you can use in order to be more accurate with it or improve the performance of your objectives. As we said before, as we saw in Enrique's presentation, the good news here is that we no longer need to be experts in algorithms in order to build our own machine learning models. There are tools like big MLs that will allow you to click and point and essentially use either a web front or an API in order to abstract yourself from the specific mathematics of the algorithms. All right, now we saw there were different types of algorithms. There are the more traditional machine learning algorithms, the workhorses of machine learning, and then there is the deep learning craziness that we have been living the last years, and in which, by the way, there is a lot of hype as well in terms of the capacity of what we can do with them. So I wanted to provide a little bit of evidence from the market, what people is actually using in the field. And there is a great survey from Kaggle every year. This is more than 20,000 respondents. 1/4 of them are students, but the rest are actually data scientists and actual practitioners doing data science. And in last year, what we saw is that out of their response, as you can see on the left-hand side, we can see that in reality, people are using still the majority of their work, or the majority of the time, they are using traditional machine learning models and algorithms like linear regression, logistic regression, decision trees, or ensembles. Those are like the winning algorithms when you really want to make things work, and those are the workhorses that you use in order to build your models. There is an increase in the use of neural networks, so don't get me wrong, I believe this deep learning is definitely something you need to have in your toolbox, and it's extremely useful for specific use cases, particularly when you have unstructured data, or you need to deal with images and sounds and video. And you can see that there is an increase in the use of convolutional neural networks or recurrent neural networks as well, and probably more to come in the future as those get more extended into the community and the actual use cases that they can tackle. All right, so beyond the actual abstraction of the algorithms and the models, I wanted to provide also a quick overview of what is behind, what is supporting the normal work when you build a machine learning model. And what we have here is the architecture of a machine learning platform. This is BigML in this case, and this is the typical architecture that will render the service for you to build your own machine learning models, and on top of them, your machine learning driven applications. And all start with having the right infrastructure, like in the case of BigML, which is auto deployable and auto scalable, and allows you to effectively forget about how the hardware is taking care of the computation there. And on top of the actual infrastructure layer, like in the case of BigML, there is a lot of development and a lot of server backend specifically tailored in order to tackle machine learning tasks. It's not the objective of this presentation to get into details, but happy to answer questions if you're interested in that part. And on top of that, probably the most important element is the API. And the reason why API is so important is because it will allow you to programmatically improve your applications and integrate them seamlessly across different systems and different pieces of software or other elements that you may need to effectively integrate your machine learning driven application with. And this is very important because as I mentioned before, what the problem today for many companies is to move from the sandbox, from the development of machine learning models in a sandbox to actual production, and using them integrated, using the machine learning models and the machine learning applications integrated in real time with the existing legacy systems. And for that, APIs or API services are proven to be one of the most robust mechanisms in order to do that. On top of the API, by the way, you have tools and other interfaces that will allow you to, or will facilitate your work when you are modeling as well. Visualizations are very important in order to export your data. Also, the web dashboard that allows you also to deal with the API without noticing, and the ability to once you have used those tools on top of, as another abstraction on top of the API, go down to the API and actually bind your work with other programming languages if you really need to custom your development towards a specific objective, which is what many companies need to do at the end. Okay, so a little bit quick update on the hype curve here. As I mentioned before, one of the problems we have today in the market, in the industry, is that there is a lot of hype. So it's very difficult to find the actual truth and the reliable resources amid all the noise that is out there. So it's important that we stay away from the AI hype and many of the media headlines in order to really profit or benefit from the technologies that have matured and we have at our disposal. So this is the Gartner hype cycle for artificial intelligence. As you can see, machine learning is quickly going through the of disillusionment, which is a very good thing. It means that the hype is getting over, and machine learning is very quickly going to be acknowledged as a more mature technology, and it will get into massive adoption. It's happening very quickly, and I'll show you later on more data in terms of companies that are actually moving very quickly into the machine learning platform world. By this estimation from Gartner, we could say that we are 2 to 3 years ahead of really mainstream adoption, like literally everyone using machine learning in production, not only in the sandbox, not only exploring machine learning applications or developments, but actually using it in practice. On the right-hand side, there is another report from Gartner that I wanted to show you as well. specifically because there are some components from machine learning that are becoming are very quickly getting into the hype curve. Some of them are reinforcement learning or AI cloud services, which is another version of the machine learning platform concept, if you will, explainable AI, machine learning operations, and particularly AutoML. The AutoML in particular is now at the top of the hype, which means effectively that there is a lot of awareness around this concept, but specifically people are having higher expectations than the actual reality, which means that the technology is not yet mature enough, or is there is an overpromise on what it can do. I'll get into more details later on, but it's important to bear in mind that I am expecting also AutoML to mature very quickly as machine learning and get ahead of the curve, of the hype curve, very quickly as well, in 1 or 2 years as well. And then back to the overall transition between open source and tools, products. I wanted to be more specific on how this slide about adoption refers to machine learning platforms. What has been happening is that in the past we have seen many machine learning platforms built based on open source. I would say many. I will refer to them in more detail, like in the case of Facebook, Learner, or Uber, Michelangelo, or companies like Airbnb with Big Head. They have built internally during years their own machine learning platforms based on open source components primarily. And what we see now is that we are at this point in which we are going over the threshold in which it doesn't make sense to go on building your machine learning platform internally based on open source, because the business case will most likely justify that buying or licensing the product from a vendor is going to be more relevant and advantageous for your company. I'll provide more specific details later on, but we are at that point in which it makes more sense to consider proprietary products or vendor products rather than building your own open source platform internally. And that's particularly true for many companies that they don't even have the competencies internally to do that. So we are at that level of transition in which many more companies are going to jump into the machine learning platform wagon and ultimately develop those efforts by using those tools. Okay, so adopting ML at scale. The big problem with machine learning, as I mentioned earlier, is that it's proving to be extremely difficult to move from the sandbox, from the exploration phase into the production phase, or effectively putting your models into work integrated with the legacy infrastructure that you have and the legacy processes that you have. And we have data from Gartner and that proves that the companies are really struggling to move from this development phase into the deployment phase. It's only a few % of companies that are reporting from year to year, from 2018 to 2019, that they have been able to deploy their models after building them, nearly 5% of them. Not only Gartner is saying that, this is consistent with the survey from Kaggle and others. IDC is reporting the same thing. Accenture reports also say that this is one of the main problems in every single company after development of those models and proving that they are working. Being able to exploit them is the big problem there. In the case of Kaggle, we can see here that from year to year, this is 2018 compared to 2019, a small percentage of respondents is saying, okay, we are moving from exploring into models that generate insights on the left part of the graph, and the other part moving from using machine learning methods and having models in production for more than 2 years. There's again only a few percentage of new respondents that have been able to move year on year from development to production. So definitely everybody is having a problem there, and it's very much related with certain barriers they find in order to integrate their models into the legacy systems that they have. One of the problems is what we call technical debt. And there is a great article. I posted the reference there, the hidden technical debt in machine learning systems, and that was published by Scully and others at Google during NIPS in 2015. But I really recommend to read this one because it's literally golden. It technically explains everything that happens in practice when you try to really marry the machine learning operations with the existing IT operations that we have, the practices, the traditional software practice that we have in the companies today. The conclusion from that is that the experience shows that because of how rapidly the world is changing and there is no stability out there, the changing nature of the world makes that our sources of data and our sources of technical debt are significant, and we need to bear those in mind in machine learning. This is the concept of models becoming old, because when we train them with data, we are effectively taking a picture of the world at a specific point of time. We train the model with that particular data, and the model will learn from that data. But as long as things change in the world, that data becomes more old and obsolete, and your model, as a consequence, also becomes older and starts to drift in performance. And that's one of the most important problems also to solve when thinking about applying machine learning. Now, not only that, but everything that you have around your specific machine learning code, you have things like data collections or new data collections is you need to retrain your model, feature extraction, feature engineering, analysis, process management, evidently all the serving infrastructure. So all this complexity, adding, as I mentioned before, the problem of your models aging, makes imperative that you have a tool or a platform that will allow you to tackle this complexity. This is what we call a machine learning platform. So effectively, a machine learning platform should be able to facilitate all these processes in a way that you can effectively integrate your machine learning code and your machine learning models into your business processes. Okay, so how many models are too many models? And we have the example from Facebook, by the way, which is really revealing. And in the case of Facebook, they reported, and this is part of their announcement of FB Learner. FB Learner is the official name for Facebook machine learning platform, which is an internal, mostly open source machine learning platform that they use for their engineers and different departments to develop their machine learning based applications. So back in 2016, so this is history now. Back in 2016, they reported more than 1 million models trained, rendering 6 million predictions per second. And more than 25% of the engineering team using it. Engineering team meaning engineers from different departments, marketing, sales, advertising, many different departments. So this is a clearly revealing of how far a company can go in terms of using machine learning. Obviously, this is an extreme example, but as you can see also from the table here, there are other sectors like retail in which you eventually may have tens of dozens of models for specific use cases, or like in healthcare, where you have thousands of machine learning models. Financial services is also in the hundreds, and I would bet that now financial services companies are moving from hundreds into thousands of models in using machine learning. So depending on your sector, your specific operations as a company, you may have a different level of use or needs with machine learning models. But we can see also that the companies are evolving very quickly. And for instance, Facebook was reporting this amount of use, more than 1 million models trained back in 2016. I am positive that probably by this time they will be most likely double this level of use of machine learning models. So again, what we have is definitely the need to use platforms or solutions, systems that will enable us to tackle all this complexity. And as we saw before, there are cases in which we can use more traditional methods like rule-based methods and traditional software because things never change and are more stable. But on the other side of the spectrum, when things are always changing, and this is the case for online services, the case for Facebook and their timeline, for instance, or real-time transactions or online transactions, on the other side of this spectrum, things are changing very quickly, and definitely you need a specific platform to tackle that particular problem. And examples of people who have already put those machine learning platforms in place, again, for internal use, Uber, Facebook, Twitter, LinkedIn, Airbnb, Lyft, Netflix, Spotify, eBay, Amazon, and later on companies like General Electric, AT&T, and other more oriented to utilities. There are many more, but this is an example of the people or the companies that were doing that back in 2016, 2017, and years past. Based on that, let's have a look at the market for machine learning platforms very quickly. So in the case of Amazon, it's ubiquitous. I mean, Jeff Bezos was specific in their letter to shareholders. Machine learning is going to be horizontal, is an enabling layer for every operation within Amazon. So clearly, they are using it literally for every business process in which they have enough data available. And that's the case for many other companies as well. This is a list of the public announcements from technology companies on using using and having internal machine learning platforms. So if we review this very quickly, we see that, for instance, Facebook announced FB Learner back in May 2016. Google open source TensorFlow back in 2017, in August. Netflix announced their notebook data platform in 2018. Uber 2017. Michelangelo, which by the way has many similarities with things that Airbnb and Facebook have been doing. Twitter announced Cortex, their internal machine learning platform, back in 2015. The point here is that this is really history. We are now sitting in 2020, and what we have seen is that all these big companies, obviously they are at the forefront of technology and their business is pretty much online driven. They found the need to have an internal machine learning platform to develop their machine learning models several years ago. And by the way, this is the public announcements, which means they have been working on their internal machine learning platforms probably 3 or 4 years earlier in order to have the product available for their engineers and the different business stakeholders. So this is already history. So this means that effectively is up to the rest of us, to the rest of the companies, to follow suit and eventually consider having a machine learning platforms whenever the use cases, the number of use cases increases internally. Why these guys did that back in 2016, 2017 is because when you adopt a machine learning platform, you are effectively having an unfair platform advantage against your competitors. Simple things. You benefit from applying machine learning, you optimize your business processes, you profit from that, and the sooner you can implement that in volume at scale, the better for you and the more competitive you will become. So that's essentially the underlying reason for that. More examples of machine learning platforms. Again, public announcements from other companies as well. eBay, of course, Lyft, actually January this year, AT&T, which is a telecom company, back in 2017, Spotify last year, Delta Airlines also announced their AI code platform, which is actually licensed. General Electric's, which is internal machine learning platforms oriented specifically to IoT, KT Telecom, and which is a Korean telecom player as well, and the list goes on and goes on and goes on. The decision here is to build or buy your machine learning platform, and this is essentially and ultimately a business case decision. In the case of custom building your machine learning platform, the benefit is that you will get a highly customized solution, which is probably in some cases the right choice. The drawback here is that it is expensive, it requires time, so there is a time delay between starting your project and having actually your own machine learning platform operational, and it requires a strong engineering talent and teams, which is again very expensive. The buy option will most likely require that you adapt and you go through the learning curve of that particular vendor proposition, but will be in market and in operations sooner, because it demands less time and expertise from the actual users in your company. The other big advantage of relying on a third party is that you will have continued access to innovations. Effectively, a vendor, and BigML is a perfect example of that, will make sure that the latest available algorithms and innovations are incorporated in the platform for all their customers. And that's a way to secure that you are also having that functionality immediately available when it is ready, rather than having to incorporate that and develop yourself that particular functionality. But again, this is ultimately a business case decision, and I have a ROI calculator in the next slide that we will go through very quickly. What has happened is that most enterprises will ultimately consider a commercial or a cloud-delivered software solution. Is going to be cheaper, is going to be faster, and is going to be more easily put into operations in your company. Here is also a partial list of machine learning platform licensees from BigML, and you see a lot of companies, not necessarily the big technology companies from Silicon Valley, obviously, that have already started their machine learning efforts by licensing the platform to BigML. This is an ROI calculator, which shows you a very quick exercise in order to analyze if it makes sense to make your own effort, build your own platform, or if it is better to actually hire or buy a third-party solution. So the assumption here is that the average value you can generate for each operationalized project is in the range of $300,000, which is not that much. Actually, we have seen many companies doing much more. Many companies actually have a savings per year, which is in the range of $300,000 per year. Anyway, this is for 1 year only, so we are assuming that you can generate profits or revenues in the range of $300,000 per successful project. Now, you have on the left-hand side company A, which is developing your own internal effort. Company B will effectively rely on a data science or machine learning platform. What you see here in red is actually the costs of primarily employees that you will need to bear if you decide to develop your own project. So simple things: the data scientist salaries, recruiting costs, software costs, IT costs. So essentially, in the case of the company A building their own machine learning platform or doing their own development, the actual cost can stack up as much as $7.5 million. With a data science platform, the total cost, including also the people that will need to run and use and manage the platform, is in the range of 5.8. This is obviously debatable, and each company will be different, but it shows you the way we may want to think about this when we want to make our own business case. So essentially what happens at the end, if you roll up all the costs and the benefits, and assuming that in the case of the successful data projects, we get to a 25% successful rate. So not being very ambitious, but even using a vendor product, let's say that only 1/4 of all the efforts, all the projects that we do are successful. The benefit will rack up to mostly in the range of 29 million. In the case of the company doing their own efforts, the number of projects you can effectively operationalize is lower, because you really rely on people, on human work, and many times is about silos, talking to other silos. the successful rate of implementation of projects is lower, is 15%. In view, ultimately, make the ROI analysis, you will get to a point in which for each dollar invested in data science, it pays out to 1.4 in the case of building or doing your own effort. While where you rely on an existing platform, you will essentially get as much as $5.1 per each dollar that you invested in that way. And that's essentially what is happening, and the reason why we are going through this threshold from moving away from the traditional open source components into a more mature market in which there are solutions, like the case of BigML, in which you can rely in order to bring more and more projects and more quickly get your models into operation. Okay, as I mentioned before, there are plenty of mature solutions in the marketplace, so it's no longer that you need to really go all full stack and develop your solutions. There are plenty of options in the market, mature enterprise platforms that you can leverage in order to do your efforts, your machine learning efforts, and develop them. Here are two graphs. The graph on the left-hand side is about machine learning as a service vendors, and the right part of this graph is on-premise machine learning platform as software, on-premise or hybrid solutions in some cases. So typically a company will start learning or going through the learning curve of using machine learning on developing models. And for that, probably the right advice is to start on the left-hand side and using machine learning as a service, because it's inexpensive and it's the easier way. Once you have your use cases validated, once you have your early models working and they are promising candidates to be used into production, then you can move into a more full-baked solution that eventually you may want to have on-premise. And then you move into on-premise setup behind your firewall that will solve your specific problem. Companies that you can see in this space, Google, IBM, Microsoft, all the big players are there. Amazon, of course. Other important mention are the challengers in this space, more specialized companies, and those are the likes like DataRobot, H2O, BigML, of course, Dataiku, and some others like RapidMiner as well. But definitely there is no shortage of solutions. Each platform has different flavors, different functionalities, so it depends also on what sort of use cases and specific needs your company may need. Is better one product or another. We will see with AutoML the differences between the different platforms and how eventually you may want to consider one or another depending on the functionality there.
Hi, Ed. This is Maria again. Just a reminder, we have 5 minutes to go of your presentation, and instead of time for questions and answers, we can use the virtual coffee breaks for that. But just so you know, 5 minutes more.
Okay, I need to rush then. So very quickly, this is the platform going mainstream. This is all the customers that I've been able to grab from public sources, from H2O, from DataRobot, from BigML. So there is a list, really a huge list of customers that have already licensed machine learning platforms. So you can see that this is really moving very, very fast. So let me move very quickly. Okay, we saw Facebook, we saw also Uber as examples of machine learning platforms. This is probably, I'll stop here. One of the revealing things for me was Uber explaining how they went through from zero to really deploying their machine learning platform internally, and what was their approach towards making sure that things were as automated as possible. They started with what they call consultations, which is having the specialist spread inside their company to really teach others how to use the machine learning platforms. Then they automated the workflows to make sure that those workflows were working for different departments, different use cases. But finally, what really was hitting the ball out of the park was having the right platforms in place. And actually not only one in their case, because they have sort of a fragmented approach, but having the machine learning platform that was really delivering the necessary functionality to tackle all those use cases. So bottom line, if you want to really make sure that you benefit from the AI, what they call AI wave, and make sure that your machine learning models get into production and you benefit from a business perspective, there is a strong recommendation to use machine learning platforms for that. Either building your own, or if you are in a hurry to get into market, consider the available vendors in the space.